Good evening. In this session, I am going to explain you problems given in previous Jeemain from the topic system of particles. In particular, from this topic, we are going to see problems based on center of mass and torque. So, let us move on to the problems. Look into the first problem. See, center of mass and torque based problems I am going to discuss in today's class. So, a rod of length 5L is bent at right angles keeping one side length as 2L. If this length is 2L, this length is 3L. Position of center of mass of the system you need to find. Consider length of the rod as 10 centimeters. So, consider L as 10 centimeters. The total rod length is 5L, that is 50 centimeters. See here, along x axis and this is along y axis. Along x axis 20 centimeter long rod is placed and along y axis 30 centimeter long rod is placed. And as it is a uniform rod, mass is proportional to length. So, let its mass be 2m, then its mass will be equal to 3m. Let us take this as the origin. See here, let us write the coordinates. Coordinates of this. This is, we consider this portion of the rod as a body whose mass is concentrated at its center, that is at center of mass. So, 2m has coordinates 10, 0 because it is along x axis and this 3m is along y axis. So, it has coordinates 0, 15 because its center of mass will be at the center of the rod. Now, the formula for x coordinate of center of mass is m1 x1 plus m2 x2 by m1 plus m2. Similarly, y coordinate of center of mass is m1 y1 plus m2 y2 by m1 plus m2. So, substituting in these two formulae, x coordinate of center of mass is m1 x1, that is 2 into 10, m1 y1 is equal to 0 by m1 plus m2, 2 plus 3, 5. Actually, 2m, 3m, 5m, m anyway it gets cancelled. So, x center of mass is, or x coordinate of center of mass is 20 by 5, that is 4 centimeters. Similarly, y coordinate of center of mass is m1 y1 plus m2 y2, 3m into 15 or 3 into 15 divided by 5m, anyway m gets cancelled. So, it is 45 by 5, it is 9 centimeters. So, y coordinate of center of mass is 9 centimeters, but if you look at the options, they are given in the vector form. So, position vector of center of mass is 4I bar plus 9j bar expressed in centimeters. So, here 4I plus 9j, that is the right option for that problem. Move on to the next problem. A uniform rod of mass 250 grams having length 100 centimeters is balanced on a sharp edge. Let this be a uniform rod of mass 250 grams, length 100 centimeters. Let us take this end as a reference. So, this will be 50 centimeters and because it is uniform, its mass appears to be concentrated at its center. So, mass of the rod is given as 250 grams, total length is given as 100 centimeters. It is balanced on a knife edge placed at 40 centimeters division. So, the knife edge located at 40 centimeters division exerts force in the upward direction. A mass of 400 is suspended at 10 centimeter mark. So, here this is 10 centimeters mark and a mass of 400 grams is suspended at that point. To maintain balance of the rod, what mass should be suspended from 90 centimeters mark? See here, to maintain balance of the rod, that means the rod must be in equilibrium position. So, if it is in equilibrium, net force on it must be 0, net torque must be 0. Net force means sum of the upward forces must be equal to sum of the downward forces. Net torque means with any reference point of the rod, the sum of the anti-clockwise moments must be equal to sum of the clockwise moments. So, here let us take this fulcrum, that is the point at which the rod is supported on a knife edge. Let us take it as the balance point. About that point, this 400 creates a torque in this direction, 200 weight creates a torque in this direction, and this M also creates torque in this direction. This is anti-clockwise moment, these two are produce clockwise moments. Sum of the anti-clockwise moments is equal to sum of the clockwise moment. Moment is the product of force and its perpendicular distance from the point of reference. So, here if this is 10, this is 40, this distance is 30 centimeters and this distance is 10, and from 40 to 90 this distance will be 50. So, torque of this 400, that is anti-clockwise torque, force into perpendicular distance is 30. Actually force is mg, but throughout that g gets cancelled, that is why I am just taking m. So, mass into perpendicular distance, this is anti-clockwise moment, this produces clockwise moment. So, this is 250 into 10. This also produces anti-clockwise moment plus clockwise moment m into this distance is 50 centimeters. So, here if you look at it very clearly, this 50 can be taken as common factor and cancel. So, this is 830 240 minus 50 is equal to m. So, from this m is equal to 240 minus 50 is 190 gram. So, this is the correct option for that problem. Now, next one, find out the torque due to that force about the origin acting on a particle whose position vector is. So, position vector of the force about the reference point is given as I bar plus j bar plus k bar, and the applied force is given as 2I plus j plus 2k. You are asked to find torque. Torque is equal to R bar cross F bar. So, here if you take the cross product, it is the determinant of these two, I, j, k, 1, 1, 1, 2, 1, 2, 2, 1, 2. So, here from this torque will be I bar into 2 minus 1, 2 minus 1 minus j bar into, if you close this, 2 minus 2, it is 2 minus 2 plus k bar into, if you close the row and column of k bar, 1 into 1, 1 minus 2, 1 minus 2. So, torque is equal to 2 minus 1, 1, I bar, 2 minus 2, 0, 1 minus 2, minus 1, k bar. So, torque is I bar minus k bar, option D is the right answer for that problem. Move on to the next. Look here, exactly similar model. You have to do all by yourself. By the time I complete the problem, you have to complete this problem in your notebook. Get ready. Look here. So, position vector of the force is given as 2I plus 2j plus k. force vector is given as 5i plus 3j minus 7k. So, position vector is 2i plus 2j plus k, force vector is 5i plus 3j minus 7k. Torque is equal to r bar cross f bar. Now, we can write it directly. Instead of, I am just skipping one step, I am not putting that determinant form. So, I bar into 2 minus 7 minus 14 minus 1 into 3 minus 3. Okay. So, option is done because minus 17i is only with the option. In the exam, confidently you can pick up the answer, but let us try. Minus j bar into 2 sevens are minus 14 minus 5 plus k bar into 2 3s are 6 minus 10, 6 minus 10. So, this is minus 17i, minus of minus becomes plus 19j minus 4k bar. So, the option C is right. See, you have to be smart. Just by completing this, you could pick out the option because there is only one option starting with minus 17i. Okay? Now, go to the next problem. Angular momentum of a single particle moving with constant speed along the circular path. See here, this is the radius vector. If it is moving with constant velocity, this is the linear momentum. Angular momentum is r bar cross p bar. That is given by Fleming's left hand rule or Maxwell's corkscrew rule. So, the direction of angular momentum will be perpendicular to the plane containing, okay. So, perpendicular to the plane containing the plane of rotation. So, here the direction of angular momentum is always constant. It will be like this, and as the magnitude of r and mv is constant, magnitude is also constant. So, the angular momentum remains the same in magnitude and direction. So, option B remains the same. The angular momentum remains the same in magnitude and direction is the right option. So, in case of a body moving in a circular path with constant speed, that we call it as uniform circular motion. So, in case of uniform circular motion, angular velocity is constant, angular momentum is constant, hence torque is 0. Okay? So, move on to the next problem. 4 point masses are fixed at the 4 corners of a square of side L. The square is rotating with angular frequency omega about an axis like this. Okay, angular momentum of the square about this axis. Angular momentum is I omega. So, you need to find out I. I is equal to 4 point masses. One mass is here, one mass is here, here, here. This is a square of side L. So, here suppose if this is a rigid body, this is the axis of rotation. It has a number of particles, say m1, m2, m3, so on, at perpendicular distances r1, r2, r3, so on. Moment of inertia of system of particles about an axis of rotation is m1 r1 square plus m2 r2 square plus m3 r3 square plus so on, where r1, r2, r3 are perpendicular distances of the particles from the axis of rotation respectively. So, just we are using that formula to find out moment of inertia of this system of particles about this. As this point particle is on the axis, it does not contribute anything. So, what is the perpendicular distance of this from the axis? This is equal to this distance. So, these two perpendicular distances are L by root 2, and perpendicular distance of this from the axis, that is the diagonal length, it is root 2 L. So, just I am redrawing that, right. This is the axis. So, its perpendicular distance, this is L by root 2, this is also L by root 2, and this distance is root 2 L. Here this is M, this is M, this is M, this is M. As this is on the axis, its distance is 0, hence its moment of inertia with respect to that point is 0. For this, M into L by root 2 whole square, L square by 2. For this, M into root 2L whole square, 2L square. For this, M into L by root 2 whole square, L square by 2. ML square by 2 plus ML square is ML square plus 2ML square. So, moment of inertia of that 4 particle system about this axis is 3ML square. But you are supposed to find angular momentum about that axis. Angular momentum is I omega. So, this is 3ML square omega. So, this is the correct option. 3ml square omega is the angular momentum of the system about the axis shown. Now, look here. See here, actually the diagram is missing in this, I forgot to paste the diagram. See here, actually this is given like this. 3 point particles of masses 1 kg, 1.5 kg and 2.5 kg are placed at the 3 corners of a right angle triangle of sides 3 centimeters, 4 centimeters, 5 centimeters as shown in the figure. Actually, this is the figure given. Here 1 kg mass is placed, here 1.5 kg is placed, and here 2.5 kg is placed. This is given as 3 centimeter side, this is given as 4 centimeter side, this is given as 5 centimeter side. That is actually given diagram in the original paper. I forgot to paste that diagram here, but I remember. Okay. Now, look here. So, the center of mass of the system at a point with respect to 1 kg. This 1 kg is taken as the reference point, that is origin. Now, let us write the coordinates with respect to this point. This is actually x coordinate is 3 and y coordinate is 0 because it is taken on x axis, and let us consider this as y axis. So, its coordinates are 3, 0, its coordinates are 0, 4. So, x we can write the masses and the coordinates like this: 1 kg mass with coordinates 0, 0, 1.5 kg mass with coordinates 3, 0, 2.5 kg mass with coordinates 0, 4. So, what are the formulae we have? X coordinate of center of mass is m1x1 plus m2x2 plus m3x3 by m1 plus m2 plus m3. Similarly, YCM is m1y1 plus m2y2 plus m3y3 by m1 plus m2 plus m3. See here, using that relation, m1 x1 0, m1 m2 x2 1.5 into 3, m3 x3 0 divided by m1 plus m2 plus m3, it is 5. So, x coordinate of center of mass is 3, 1.5s are 4.5 by 5, it is 0.9. So, 0.9 centimeters right of 1 kg. How many options are there with 0.9 centimeters? Only one option. Actually, that is done. But let us try the y coordinate also. Y coordinate of center of mass is m1 y1 0, m2 y2 0, m3 y3. 2.5 into 4, that is 10, divided by m1 plus m2 plus m3, it is equal to 2 centimeters. Y coordinate of center of mass is 2 centimeters, implies it is 2 centimeters above 1 kg mass. So, that is perfectly correct option, right. Now, next one, look here, shown in the above figure, a rigid body and a uniform rod of 1 meter long rod AB is held in horizontal position by 2 strings tied to its ends and attached to the ceiling. The rod is of mass m. As it is a uniform rod, its mass will be concentrated at its center. Because it is 100 centimeters long rod, its mass is concentrated at 50. Rod is of mass m and has another weight of mass 2m hung at 75 centimeters. In the next page, actually the question is given, what is the tension in the string A? So, we need to find out the tension in the string, right. So, here the rod, now here it is like this, okay, suspended at its ends. You need to find out tension here. So, this is the reference point A, and at 50 centimeters division, its weight mg is acting. Anyway, g gets cancelled throughout, that is why we are not mentioning g, and at 75 centimeters, another load of mass 2m is suspended. Okay, you need to find out the tension in this rod. So, let us take this point B as the reference point. Okay, with respect to B, this tension creates clockwise moment, these two create anti-clockwise moment. Sum of the clockwise moments is equal to sum of the anti-clockwise moments, isn't it? So, here the clockwise moment is T into this perpendicular distance is 100, that is equal to, this is anti-clockwise moment, this is clockwise, that is m into this perpendicular distance is 50, this is also clockwise. So, this is 2m into 75. So, let us simplify. If you look at it, very obviously you can cancel 50 throughout. So, here 75, 25. So, actually 2 75s are 150. In 150, 50 gets cancelled 3 times. So, 2t is equal to m plus 3m, that is 4m. Is it correct? So, 2t is equal to 150. Okay. So, t is equal to 2m. That is the tension, or if you express it in terms of weight, 2 mg. Okay. So, let me check it once again. See here, this is m, this is 2m. So, okay, there is a mistake in the problem. See here, instead of see here, just there is a small mistake, very small mistake, because of which answer is being changed. See, this is perfect. So, here clockwise moment about this point, that is t into 100, that is equal to this is anti-clockwise, this is clockwise, that is m into 50. See, actually the mistake is, I said we are taking this as the reference point, isn't it? So, if you take that as a reference point, look here, this tension about this creates this moment, and these two about that point create in opposite direction. Moment of this tension about this point is t into 100. Moment of this about this point in this direction, it is m into 50. Moment of this 2m about this point is, this distance now is 25. That is the thing. Okay, you can cancel 50 throughout. 2 25s are 50, 50, this is 2. So 2t is equal to m plus m, 2m, or t is equal to m gram weight or mg Newton or mg dyne. So this is the correct option for that problem. Okay, I am just repeating that question. Here a uniform rod is suspended at its ends, okay, from two rigid points. You are supposed to find tension here, and it is a rod of length 100 centimeters, its mass is m. At 75, 2m is suspended. So we have taken torques about that point. So torque of this is in this direction, for this in this direction, T into 100, it is equal to m into 50 plus 2m into, this is 75, so this becomes 25, 25. If you take 50 as a common factor, 2t is equal to 2m, t is equal to m, or if you express that in mg, it is mg. Move on to the next problem. Look here. 4 particles A, B, C, D with masses A, m and at B 2m. This is 2m, at C 3m, at D 4m are placed. They have accelerations of equal magnitude as shown. Find the acceleration of center of mass. See here, I am redrawing that diagram, right? See here, acceleration is in this direction, mass is m. Acceleration is in this direction, mass is 4m. Acceleration is in this direction, mass is 3m. Acceleration is in this direction, mass is 2m. Let us take this as positive x-axis, this as positive y-axis. We know acceleration of center of mass is m1 a1 bar plus m2 a2 bar plus m3 a3 bar plus m4 a4 bar divided by m1 plus m2 plus m3 plus m4, isn't it? Now we have to write it very carefully. This is along negative x-axis, so minus m a bar, okay, or minus m a I bar, because it is minus I bar. A2, m2 is 2m, 2m along positive y-axis, 2ma plus j bar. 3m along positive x-axis, 3ma positive x-axis is I bar. 4m along negative y-axis, minus 4ma negative y-axis, so minus j bar, divided by sum of the masses, m plus 2m, 3 plus 3, 6 plus 4, 10m. You can take m as a common factor and cancel, then you will be left with what? So acceleration of center of mass is, look here, minus ai plus 3ai. It is 2ai, 2ai, 2aj minus 2aj, minus 4aj. 2a minus 4a is minus 2a j bar, divided by total mass is given as 10 here. So this is 2 by 10. If you take it as common factor, a also you can take it as common factor, I bar minus j bar, or this is acceleration of center of mass is a by 5 I bar minus j bar. This is, so a by 5 I bar minus j bar is the answer. Okay, that is the acceleration of center of mass. Move on to the next. Look here, 3 particles are arranged at the vertices of an equilateral triangle as shown. Find the coordinates. See here, I am just redrawing the same thing. This is an equilateral triangle of side, how much? 1 meter. Side length 1 meter. 3 particles. This is taken as the origin. Here 50 gram mass is placed and here 100 gram mass is placed and here 150 gram mass is placed, right? The xy coordinates of center of mass with respect to this. So, let us write the coordinates. This becomes 0, 0. This is 1 meter long. So, its coordinate is 1, 0 because it lies on x-axis. You have to be very careful while writing the coordinates of this. So, its x coordinate is half the side, that is 0.5. Y coordinate is height of an equilateral triangle is root 3 a by 2, that is root 3 by 2, a is 1 meter. So, let us write the coordinates and masses and their respective coordinates. For 50, 0, 0. For 100, 1, 0. For 150, see here 0.5, 0.5 root 3. It is root 3 by 2 into 1, that is 0.5 root 3. So, x coordinate of center of mass is m1 x1 0, m2 x2 100 plus m3 x3 150 into 0.5 divided by m1 plus m2 plus m3 50, 150, 300 by 300. So, here this is 150 into 0.5 is 75. So, 175 by 300. So, 25, 7 times, 12 times. So, x coordinate is 7 by 12. As there are 2 options, definitely you have to find out y coordinate also, because we cannot straight away pick up the right option from the 4 options given. So, again let us find out the y coordinate of center of mass. See here, m1 y1 is 0, m2 y2 0. So, 0 plus m3 y3 150 into 0.5 root 3 by m1 plus m2 plus m3 is 300. So, YCM is equal to 150 into 0.5 root 3 divided by 300. So, this gets cancelled 2 times. So, this 0.5 can be written as 1 by 2. So, y coordinate of center of mass is root 3 by 4. So, the 2 coordinates are 7 by 12, root 3 by 4. So, this option is perfectly correct. Okay, move on to the next problem. The magnitude of torque on a particle of mass of the particle is given as 1 kg and the magnitude of the torque is given as 2.5 Newton meter about the origin. Force acting on it, F is equal to 1 Newton and distance of the particle from the origin, R is equal to 5 meters. Find the angle between the position vector, force and position vector. We know torque is equal to R bar cross F bar, or torque is equal to RF sin theta, where theta is the angle between position vector and force vector. So, directly substitute the values. Torque is given as 2.5 here, R is given as 5 here, F is given as 1 into sin theta. So, from that sin theta is equal to 2.5 by 5, that is equal to half. Sine of which angle is half? 30 degrees. So, it is theta is 30 degrees or pi by 6. So, as the option is mentioned in terms of pi's, so the correct answer is pi by 6. Such a simple, that is the basic model question on torque. Okay. So, this is the last problem for today's session. Okay. Now, L and P represent the angular momentum and linear momentum of a particle of mass m with the position vector r bar is equal to a I cos omega t plus j bar sin omega t. The direction of force is of something given. So, force is equal to m a or F bar is equal to m a bar, right. So, force is going to be in the direction of acceleration. Okay. First, I will tell you the method at length, but we can directly pick up the answer if you have the real concept. I will tell you at the end the shortcut. Okay. Now, if this is our velocity vector is dr by dt, implies v is equal to a cos omega t derivative is minus omega sin omega t I bar. Sin omega t derivative is omega cos omega t, omega cos omega t j bar. This is velocity vector. Acceleration vector is a is equal to dv by dt. So, you have to differentiate this once again with respect to time. So, a sin omega t derivative is omega cos omega t. So, minus omega square cos omega t I bar plus cos omega t derivative is minus omega sin omega t. So, it becomes minus omega square sin omega t j bar. So, if you look at this, this is a, if you take that minus sign outside, minus I cos omega t plus j sin omega t, because you have taken that negative sign outside. So, from this what we got is a bar is equal to omega square, we have taken it outside, minus omega square into position vector r bar or displacement vector, say y bar, because I wrote y because you remember something. See, where do we see this equation? A bar is equal to minus omega square y bar. That is the equation for a particle executing simple harmonic motion. So, just by looking at this, as displacement is a single sine or cos function of time, we can say that particle is executing simple harmonic motion, where acceleration direction is always opposite to the displacement direction. So, if acceleration is opposite to displacement, force is opposite to displacement. So, just by looking at this equation, you must be able to find out the answer. So, the direction of force is opposite to the direction of r bar. That is the correct answer for that problem. Okay, I will stop here for today. I will continue with some more problems in the next session. Meanwhile, you have to complete all these problems without any ambiguity at any point. Okay, thank you and bye-bye.